Okay, so today we're going to be looking at simultaneous equations. So our learning intention is to learn the skill of how to solve two or more equations simultaneously. To be successful in able to do this, we need to be able to use the substitution method correctly. We also need to know the elimination method as well. We need to have an awareness of how many results or intersections are possible. And we also need to be able to, you might want to use graphical skills to check our validity of our answers. And we should also get in the habit of checking our answers. Okay, so the substitution method means it's a method of making one of the pronumerals the subject and then subbing what that equals into the other equation so it cancels out that pronumeral. Okay. The elimination method is trying to add or subtract the equations together in order to basically disappear or cancel out one of the pronumerals. So we'll go through some examples and I'll do both methods. Okay, here's the first example. We've got we want to solve the following equations simultaneously. We've got y equals 3x minus 1 and y equals 2x plus 5. So I've written here it's a linear and a linear. So there's a linear equation. So this is a line where the gradient of 3 and the y-intercept of -1. And this is another line. The gradient is 2 and the intercept is at 5. So we want to find where these two lines cut each other. So I'll do the substitution method first. Okay. So the first step is to label our equations. So I've got that equation. I'm going to label that as equation 1. And I'm going to label this as equation 2. Well, this is basically saying for any x value, the same x value I plug in here and I plug in here should give me the same y value. That's what we mean by solving them simultaneously. So if it produces the same y value, then this has to equal this because they're both the same y. So I'm going to sub equation 1 into equation 2. Yeah, so equation 1 says 3x minus 1 is equal to y, but that's also equal to 2x plus 5. And now I have an equation with no y's. I've only got x's, and I can solve this by using normal methods. So bringing over the 2x, so subtract 2x from both sides is x, add 1 to both sides is 6. So I now have an x value. I'm going to sub my x value into either equation, either 1 or 2, to get my y value, and these are going to be the same. So I'm going to sub it into equation 2 for the time being. So y equals 2 lots of 6, which is 12 plus 5 is 17. So therefore, the point of intersection, or where these two lines meet and cut each other, is at 6 and 17. So when x equals 6 and y equals 17, I can check it by plugging in. So 3 times 6 minus 1 is 17, and 2 times 6 plus 5 equals 17 as well. Yeah. So that's the substitution method. That is subbing the y value into the other equation, or making pronumeral and subbing it in. Okay, so we've got the elimination method. So once again, we need to label our equations. And what I want to do is I either want to add or subtract these equations so that one of the pronumerals disappears. So I'm going to subtract these two equations. So y take away y is nothing. 3x take away 2x is just x. Minus 1 plus minus 1 minus 5 is minus 6. So x equals 6. Yeah. Now we're going to sub x equals 6 into one of the original equations. So I may as well put it into equation 2 again, because we've done the working out. So y equals 2 lots of 6 plus 5, which equals 17. So therefore, point of intersection, so is at 6 and 17. Now remember, we have two lines, so quick sketch, we have that. So we have -1, and it goes up 1, 2, 3 across 1, so something like that. And we've got 5, 3, 4, 5, and it goes up 2 across 1, and something like that. Okay, so these aren't parallel, eventually they will meet. So if we look at using GeoGebra, there's my first line, 3x minus 1, and there's my second line, 2x plus 5. It meets at this point, which is 6 and 17, which is what we found out. Okay, so the solution of that is 6 and 17. Okay. Example 2, once again, we have two equations, so 3x minus 2x equals 14, negative 14, and we've got 2x minus 5y equals negative 13. Okay, so we're doing substitution method. Yeah. Label our equations, so 3x minus 2y equals negative 14, that's equation 1, and 2x minus 5y equals negative 13, that's equation 2. Okay, I'm going to, okay, from equation 1, I'm going to get and make, let's say, x the subject. So I've got 3x equals negative 14 plus 2y. And so x equals negative 14 divided by 3 plus 2y over 3. And it does create fractions, so that's okay. I'm going to call that 1a. And basically what I'm going to do is I'm going to sub my value of x into equation 2. So every time I see x, I'm going to sub in this part. Minus 14 over 3 plus 2y over 3. That's what x is equal to. Minus 5y. Negative 13. Okay, and now we can see we've just got y's in this subject. So if I'm just going to use my calculator, 2 lots of negative 14 over 3 is negative 28 over 3, plus 4y over 3, minus 5y over 1, I'm just going to make that 15y over 3, minus 13. So all I did, because I've got fractions, that's 5 over 1. If I'm going to times it by 3 on the bottom, I've got to times 3 on the top. Okay, so we have negative 28. 4y minus 15 is negative 11y. Negative 13 times 3 is negative 39 to get rid of the fractions. So negative 11y, negative 11y equals 1. Okay. Now that I've got y, I'm going to sub y equals 1 into one of my original equations, may as well equation 1. So 3 x minus 2 lots of 1 equals negative 14. So 3x equals, so that becomes negative 2. So I'm going to add negative 2 becomes negative So negative 14 plus 2 is a negative 12. X equals negative 4. Alright, I'm just going to test them just to double check. So 3 lots of negative 4 minus 2 lots of 1 is negative 14, and 2 lots of negative 4 minus 5 lots of 1 is negative 13. Yeah, so therefore, point of intersection is at negative 4 and 1. Okay. Let's try the elimination method. So once again, we're going to label our equations. Okay. I want to add or subtract the equations in order to get rid of one of the pronumerals. So far at the moment I can't do that, but what I can do is equation 1 I can multiply that by 2, and equation 2 I can multiply by 3. And what that's going to do, so times 2 is 6x, times 2 is 4y, times 2 is negative 28. And times it by 3, I've got 6x minus 15y times 3 is minus 39. So I can call that 1a and 2a, or 3 and 4. And now I've got 6x and 6x. I can actually subtract these equations together. So that disappears. Negative 4 minus negative 15 is 11. And negative 28 minus negative 39 is 11. So y equals 1. Okay, and now I'm going to basically, like I did down here, I'm going to sub y equals 1 into let's say equation 1 again, because I've done the working out. 3x minus 2 lots of 1 equals negative 14. We know that x equals negative 4. So the point of intersection is at negative 4 and 1. So once again, as I said, these are two linear equations. Yeah, and if we look, okay, there's my equation 1, there's equation 2, and it cuts here at negative 4 and 1, which is what we have as our answer. Okay. Alright, example 3. I've written down we've got a linear and a quadratic. So we've got this line and this quadratic, which is a parabola. So something, and it's a positive parabola, so if I was a quick sketch, we've got an x squared minus 3, so something that looks like that, and we've got y equals negative 2x plus 4, so we've got somewhere up here is 4, and we're going down to across 1. Alright, something that looks like this. Now if we drew this parabola, and we have this line, we expect to get 2 points of intersection where they could happen simultaneously. So we have a quadratic and a linear that will most of the time produce 2 results. Yeah. So let's do substitution. So okay, I've got y equals x squared minus 3, that's equation 1. I'm just going to rewrite this, making y the subject. Y equals 4 minus 2x. Okay, and basically I've got y being y. I'm just going to sub 1 into 2. Okay, so I've got x squared minus 3 equals 4 minus 2x. Now I'm going to rearrange this so that we have everything kind of on one side. So let's keep this x squared. Let's bring in this 2x. And that's minus 4 from both sides, so that becomes minus 7. And that equals 0. And now we have a quadratic. We have this parabola happening. That's going to solve these 2 points. So let's just do, let's use a quadratic formula. So we want x equals negative 2 plus or minus 2 squared minus 4 lots of 1 minus 7 all over 2. So 4 minus 4 lots of negative 7. So 32. That's dividable by square root of 32. That's 16 and 2. Okay, and I can cancel it out. So I've got negative 1 plus or minus 2 lots of square root 2. Okay, so then there's my 2 possible x values. Okay, so when x equals negative 1 plus 2 square root 2, I'm going to sub that into, may as well sub it into equation 2. I get y equals 4 minus 2 lots of this. So 4, that becomes plus 2, and becomes minus 4 square root 2. So we get 6 minus 4 square root 2 as one value. So, and then when x equals minus 1 minus 2 square root 2, um, 4 minus 2 lots of negative 1 minus 2 square root 2, plus 2 plus 2 square root 2. So we get 6 plus 2 square root 2. Oh no, sorry, 4. Okay. So we get the points of intersection is we get negative 1 plus 2 square root 2 and 6 negative 4 square root 2 and negative 1 minus 2 square root 2 and 6 plus 4 square root 2. Okay. So it's a long process, but you get 2 solutions. And if we looked at our graphs, there's my parabola there, and there's my straight line. And obviously, this program gives us as decimals, right? And so we can plug in these decimals. So if I was to do negative 1 plus 2 square root 2, that's positive 1, so that's the other one. So negative 1 minus 2 square root 2 is negative 3.828, yeah. And 6 plus 4 square root 2 is 11.65, which corresponds to our graphs, okay. Okay. If we did elimination method, so So you still have your y equals x squared minus 3. So that's equation 1. And then you have your, once again, I'll just rewrite it as y being the subject. I'm going to move it over here. Okay, 4 minus 2x. Okay, now if we're going to subtract 1 from 2, like we did in polynomials, that cancels out. There's no x squared that I can cancel. Okay, minus minus, the 0 minus minus becomes a 2x. And then negative 3 minus 4 is minus 7. And so what we do is we end up having this equation again. Yeah, and then you just continue on how we did before to solve and find the points of intersection. Okay. All right, so here's example 4. Once again, we have a linear and a quadratic. We have, there's the quadratic, and here's our linear. Okay. So let's try, we'll do this one with elimination method to start with. Okay, so we've got y equals x squared minus 7x plus 6. That's equation 1. I'm just going to write this with y being the subject. So if I go 3y equals negative 24x plus 21, and divide it by 3, 8, yeah, negative 8x plus 7. That becomes positive, that becomes negative. Okay, so we've got y equals negative 8x plus 7. That's equation 2. So I'm going to subtract equation 2 from equation 1. So that cancels as y's. X squared minus nothing is x squared. Negative 7 minus negative 8 becomes 1x. And 6 minus positive 7 becomes negative 1. Okay. I'm going to plus and a minus. Okay. So I'm going to use, I could complete the square, or I could, yeah, may as well complete the square. So x squared plus x equals 1. I'm going to halve it and a quarter. Alright. That's going to become messy, so I'm just going to use quadratic formula. It's just faster. Okay, so I've got minus 1 plus or minus 1 minus 4 lots of 1 minus 1 over 2. So we've got minus 1 plus or minus 1 plus 4 is 5. Square root 5 over 2. Okay, rather than completing the square, I just got that straight away. So x is these two values. So we're going to sub, I may as well sub x into equation 2. So we'll do the first option, x equals negative 1 plus square root 5 over 2. 2. So y equals negative 8 lots of negative 1 plus square root 5 over 2 plus 7. So we get positive 8 minus 8 square root 5 over 2 plus 7, which is 4 minus 4 square root 5 plus 7. 4 plus 7 is 11 minus 4 square root 5. So that's one value. Now sub in x equals minus 1 minus square root 5 over 2 into 2. So we got y negative 8 negative 1 minus square root 5 over 2 plus 7. So it becomes 4. That was because of positive, so it's 4 square root 5 plus 7. So that becomes 11 for square root 5. So point of intersection is negative 1 plus square root of 5 over 2. And those two solutions. Okay. Obviously, we can substitute and should be able to get to the same place as well. Okay. If we looked at our graph, this is that quadratic, and we've got this line, and as you can see, if we get closer in, there will be a point here and a point at the top here. Okay. All right. So now we're going to try to solve 3 equations simultaneously. So the first thing is we're going to write it down and label our equations. Okay, that's equation 1, equation 2, and equation 3. Okay, so what I'm going to try to do is actually try to cancel out a pronumeral between 2 equations. So I'm going to try and cancel out the y's. Only reason because they all seem to be 1. Yep, so I'm going to cancel out the y's first. Okay, so let's say using equation 1 and equation 2, I'm going to subtract if I subtract them, I also kill out. Yeah, that's fine. So let's x minus x is 0, y minus y 0. Negative 1 minus 2 is negative 3z, and then 7 minus 1 is 6, so z's going to equal negative 2. Okay. Well, once I've found that, I can actually plug that negative 2 back into any of these equations. Okay. If I couldn't find that, I might do that, if I can, no, it looks like I'll cancel anyway. If I couldn't find that, what I'll then do is try to cancel out that same pronumeral using the other 2 equations, which will give you equation 4 and 5, and then solve 4 and 5 simultaneously because you only have 2 pronumerals. Okay, so I can sub z equals negative 2 into equation 1 and 2 and 3. Okay, so we'll get x plus y, 2 negatives make it positive, so plus 2, bring it over to the other side would be 5. We've got x plus y negative 4. Yeah, so I actually get the same equation. That's fine. That's what we want. And then we want 3x plus y. That becomes positive 6. Bring it over to the other side. Becomes 3. Okay. So we actually have equation 4 and equation 5. Okay. Let's subtract. Let's have equation 5 and we minus equation 4 from that. So 3x minus x is 2x. Y disappears. 3 minus 5 is minus 2, so x becomes minus 1. Now let's sub that into equation 4. Okay, so we get minus 1 plus y equals 5, y must equal 6. Okay, so let's just, so therefore we've got x equals negative 1, y equals 6, and z equals negative 2. We'll just test these points into our original equation. So we've got negative 1 plus 6 minus negative 2, and that should give us 7. Correct? So that's happy. Happy for equation 1. X is negative 1 plus 6. So that's plus 2 lots of negative 2 should give us 1. Excellent. So 3 lots of x's plus 6 or minus 3 lots of y should give us 9. And excellent. So that's our solution to our equations, our simultaneous equation of 3 unknowns. Okay. Thank you very much.